You remember that movie Inception, right? Where they go into a dream within a dream and everything gets weird.
Absolutely. The spinning top, a classic.
Well, today we are basically doing the tech version of that. We're putting a computer
Mm.
inside a computer. We are talking about virtualization.
Mm.
And honestly, when I first heard about this years ago, I just thought it was a cool party trick. Look, I'm running Windows 95 on my iPad.
It is definitely cool, but it's so much more than a party trick. I mean, I'd argue that virtualization is probably the single most important technology that lets the modern internet even exist.
Wow, that's a huge claim.
It's the engine room of the whole digital economy.
Okay, so today we're going to see if you can back that up. We're going to break down how you slice up one physical computer into all these digital pieces, why you'd even want to do that, and how that idea scales up to become this massive, invisible thing we all call the cloud.
It's a journey, really. From the micro, a single chip on your motherboard, all the way to the macro, to data centers the size of football fields.
So let's start at the bottom. The magic trick itself. How do you actually run two operating systems on one machine at the same time? Because usually an OS like, Windows or Mac OS, it's kind of a jealous partner. It wants all the hardware for itself.
That's a great way to put it. It really does. It assumes it owns the CPU, the RAM, the hard drive, everything. To make this work, you need a new layer of authority, a traffic cop, basically, that stands between the real hardware and all that software.
And we call that the hypervisor.
The hypervisor.
Which I gotta say is still one of the best names in tech, the hypervisor. Sounds like a supervillain from an 80s sci-fi movie.
It does sound pretty imposing, but its job is really more diplomatic. It tricks the operating systems, we call them guests, into thinking they have the whole computer to themselves.
An illusionist.
Exactly. The hypervisor just allocates a slice of memory here, a few CPU cycles there, and keeps everyone from crashing into each other.
Okay, so here's where I got a bit tripped up looking into this. I always just assumed you installed a program on Windows to do it. But apparently there are two totally different ways to do it, and mixing them up is a big deal.
It's a massive deal, yeah. Especially for security and performance. We have Type 1 and Type 2.
Let's start with Type 1. This is the one they call bare metal. Now, when I hear bare metal, I'm picturing like a black screen with green text, raw coding.
Not quite, though it is pretty intense. Bare metal literally means the hypervisor installs directly on the hardware. There's no Windows, no Mac OS, no Linux, nothing underneath it. You buy a server, you wipe the drive, and the only thing you install is the hypervisor.
So, wait. If I walked up to a Type 1 server and just turned on the monitor, I wouldn't see a start menu.
You'd see a very, very boring status screen. Maybe an IP address and a command prompt. That's it. This is stuff like VMware, ESXi, or Microsoft Hyper-V Server.
Oh, why do it that way? Why not just have a normal computer that runs VMs?
Two big reasons: efficiency and security. If you don't have a whole host OS, like Windows, running underneath, you don't have all that overhead.
Right.
You don't have Cortana asking if you want to search the web. You don't have background updates cheering up cycles. All the power goes straight to the VMs.
And the security part, how does that work?
Well, think about it. Windows has millions and millions of lines of code. That's a huge attack surface for hackers. A Type 1 hypervisor is lean, it's purpose-built, it has very little code, so it's much harder to hack because there's just less to hack. This is what runs the data centers of the world.
Okay, that makes sense for, Amazon or Google, but for me, I'm not wiping my laptop to install some server OS. I still need to check my email.
Right, and that is where Type 2 comes in. This is hosted virtualization. It's an app. You install something like Oracle VirtualBox or VMware Workstation right on top of your normal Windows 10 or 11.
So the hypervisor is just another window on my desktop.
Exactly. It's way easier to use, but it's also slower because you're running an OS inside an app on top of another OS on top of the hardware. It's just more layers.
Okay, so Type 1 for the pros, Type 2 for the rest of us. But let's talk about why the average person, or maybe the average IT pro, even needs this on their desktop. Why would I slow down my machine to run a fake computer?
I'd say the biggest use case, the one that saves the most headaches, is the sandbox.
The digital playground.
Or maybe the digital blast chamber. Imagine you get a suspicious email attachment. Or you want to test a new beta app that might be really buggy. If you open that on your main computer and it's ransomware...
You know I'm over. My files are encrypted. I'm crying. It's a whole thing.
Precisely. But if you open it inside a virtual machine...
Wait, hold on now. If the VM is running on my computer and a virus goes off inside it, isn't it still kind of on my computer? Can it just jump out?
That is the million-dollar question. And in, 99.9% of cases, no, it can't. The VM is just a file. To the virus, the VM looks like a real physical computer. It encrypts the VM's drive, destroys the VM's Windows, and it thinks it won.
But on my real computer.
You just see a corrupted file, you just delete that file, spin up a fresh copy of the VM, and you're back to work in like 30 seconds.
So it's like having a stunt double. You throw the stunt double off the cliff.
Perfect analogy.
If they break every bone in their body, the main actor is still just drinking coffee in their trailer.
Exactly. And that isolation is key for another huge use case, legacy support.
Right. This one sounds boring, legacy support. But from what I've read, this is where the money is.
Oh, absolutely. Here's a real-world scenario for you. Imagine a factory. They have this massive precision CNC machine that cuts jet engine parts. It cost $10 million back in 2005.
Okay.
The software that controls that machine was written for Windows XP. It will not run on Windows 10, period. But you can't just throw away a $10 million machine because the PC attached to it died.
And you definitely can't connect a Windows XP machine to the internet today. That's just asking for trouble.
It would get hacked in 4 seconds, yeah. So what do? You buy a brand new, secure Windows 11 computer, you install a Type 2 hypervisor, and inside that, you run a little virtual Windows XP machine that only talks to the CNC machine.
Ah, so you get the security of the modern hardware, but you keep the old, expensive stuff running. It's like a time machine.
It is. It's indispensable. And we see the same thing with developers. If you're building an app for Linux, but your company gave you a Windows laptop, you don't need 2 laptops. You just run Linux in a window.
Efficiency again. But speaking of efficiency, we should talk about the cost. Because there's no such thing as a free lunch, right? If I'm running a computer inside my computer, my actual physical computer must be feeling that.
We call this the hardware tax, and it can be steep.
So let's get specific. I got an old laptop in a drawer. It's got maybe 8 gigs of RAM, an old spinning hard drive. Can I run a virtual lab on that?
Honestly, you are going to hate your life if you try.
Yeah. Why? What's the biggest bottleneck?
It's a few things, but let's start with that hard drive. A virtual machine is stored as this giant file, often 20, 30, even 40 gigabytes. When you turn the VM on, the computer has to read and write to that massive file constantly. An old spinning hard drive just can't keep up.
It'll just feel frozen.
Completely. You absolutely need a solid-state drive and SSD for this. It's not optional.
But SSD is mandatory. Got it. What about the brain, the CPU?
The CPU matters, especially the number of cores. But there's a secret switch you need to know about. It's called VTX if you have an Intel chip, or AMD-V if you have AMD.
And this is something I have to manually turn on.
Usually in the BIOS or UEFI, yeah. Think of it like this. Without those extensions enabled, your CPU is trying to speak a foreign language by looking up every single word in a dictionary. It works, but it's slow. Painfully slow.
It's emulating the emulation.
Right. Turning on VTX is like suddenly becoming fluent in that language. The CPU creates a kind of hardware tunnel for the VM to run natively. If you don't turn this on, most modern 64-bit VMs won't even boot.
Okay, so check the BIOS. But the big one, the one that seems to kill every project, is RAM. Why is memory such a big deal here?
Because unlike CPU power, which can be shared, like, taking turns RAM is possessive, if you assign 4 gigabytes of RAM to a virtual machine, the hypervisor grabs that 4 GB from your real computer and it locks it away. It's gone. Your host OS can't touch it.
So if I have 8 GB total and Windows needs 4 GB just to run, and I give the other 4 GB to my VM.
You're at 100% usage. And here's what happens. Your computer panics. It starts using the hard drive as fake RAM. We call this swapping. And a hard drive, even a fast SSD, is thousands of times slower than actual RAM. Your mouse will stutter, your music will loop, the whole system just grinds to a halt.
So the rule of thumb is just have way more RAM than you think you need.
Always. If you want to run labs, 16 GB is the absolute minimum these days. 32 GB is much more comfortable. You never, ever want to starve the host.
Don't starve the host. Good life advice.
Oh.
So this brings us to a problem, right? VMs are great, but they are heavy. They eat RAM, they take up tons of space. If I'm Google and I need to run 1 million applications, running 1 million full copies of Windows seems incredibly wasteful.
It's efficiently inefficient is what it is, and that is why the industry started moving toward containers.
Okay, this is the buzzword I hear everywhere. Docker, Kubernetes. How is a container different from a VM?
Okay, think of a virtual machine like a single-family home. It's got its own foundation, its own plumbing, its own electrical grid, its own roof. It's completely independent, but it takes a lot of land and materials to build.
And in this analogy, the materials are my RAM and my CPU.
Exactly. Now, think of containers like an apartment complex. You have hundreds of units. They're all separate. You have your own key, your own furniture, but, and this is the key, they all share the same foundation. They share the same plumbing. They share the same electrical grid.
And the foundation here is the operating system kernel.
Yes. Containers share the host OS kernel. They don't need to boot up a fresh copy of Windows or Linux every single time. They just piggyback on the host's engine.
So they must be way, way smaller.
Drastically. A VM might be 20 gigabytes and take 2 minutes to boot up. A container might be 50 megabytes and start in half a second.
Wow.
That's how Netflix or Uber can operate. They aren't spinning up heavy VMs. They're spinning up thousands of lightweight containers that appear and vanish instantly.
That speed, that instantly appearing and vanishing. That sounds like the perfect segue to the big topic, the cloud.
It is.
Yeah.
Because really, the cloud is just virtualization taken to its absolute logical extreme.
I feel like cloud is just a marketing term people slap on everything now, like my toaster's in the cloud. But there's an actual, technical definition, isn't there?
There is. And thankfully, the government actually stepped in to clarify this one. NIST, the National Institute of Standards and Technology, created a list of 5 rules. If a service doesn't do these 5 things, it's not a cloud. It's just someone else's server on the internet.
I love that we needed a checklist to stop false advertising. Let's run through them. The first one is on-demand self-service.
This is the no humans allowed rule. In the olden days, if you wanted a server, you called IT, you filed a ticket, and you waited a week. In the cloud, you click a button and you have a server in seconds. If you have to talk to a human to get it, it's not cloud computing.
Brutal, but efficient. Okay, next is rapid elasticity. This sounds like a superpower.
It basically is. It's the rubber band effect.
Mm-hmm.
Imagine you run a pizza shop website. Usually you have 100 visitors an hour, but then it's Super Bowl Sunday. Suddenly you have 10,000 visitors an hour.
My physical server would literally catch fire and die.
Right. But the cloud detects that load and automatically spins up 10 more servers to handle the rush. Then, when the game ends, it just deletes them. That scaling up and down without you doing anything, that's elasticity.
And that ties right into the money part. Measured service.
The utility model. You pay for electricity by the kilowatt hour. You pay for the cloud by the minute or the gigabyte. When you shut those servers down after the Super Bowl, you stop paying for them instantly.
Then we have resource pooling, which is that hotel concept we talked about, sharing the hardware and broad network access, which just means I can get to it from my phone, my laptop, whatever.
Exactly. Those 5 things make a cloud a cloud.
Okay, so within that world, there are different ways to buy it. We have the as-a-service models, iOS, PyS, sauce. This always just feels like alphabet soup to me.
The best way to think of it is as a slider. On one end, you have total control. On the other end, you have total convenience.
Okay, let's start with IS. Infrastructure as a service.
This is maximum control. You're renting the raw land and the construction materials. A provider like Amazon AWS gives you a virtual server, a virtual hard drive, and a virtual network cable. That's it. You have to install Windows, you have to patch it, you have to install all your apps.
So it's a ton of work, but I can build literally whatever I want.
Precisely. Then you move to the middle. PaaS, platform as a service. This is really for developers.
This is the one I always struggle to get my head around. How is it different?
Okay, think of it like this. IS is renting an empty kitchen where you have to bring your own pots, pans, and ingredients. Pa is renting a fully stocked commercial kitchen that comes with a sous chef. You just show up and cook. You don't worry about fixing the stove or buying the pans. You just write your code. That's the cooking.
Yeah.
And the platform handles the underlying OS and all the hardware for you.
Okay, that clicks. I focus on my app, they focus on the server. And then finally, SaaS, software as a service.
This is just ordering a pizza delivery.
Yeah.
You don't cook, you don't own the kitchen, you don't even see the kitchen. You just consume the finished product. Gmail, Dropbox, Salesforce, Netflix. You're a user, not a builder.
And most of us live in that SaaS world every day. But before we wrap up, I want to double-click on something you said earlier about rapid elasticity. You said the cloud can spin up new servers instantly, but servers need network cables. They need IP addresses. They need firewall rules. How does that happen instantly? A human can't run that fast.
You've hit on the critical kind of secret piece of the whole puzzle. SDN, software-defined networking.
This sounds dry, but I have a feeling it's the secret sauce.
It is the automation of the physical world. In the old days, networking was hardware. You had physical routers and switches, and if you wanted to change how data flowed, a guy named Dave had to literally walk into the server room and move a cable from port 1 to port 2.
And Dave is the bottleneck.
Dave is absolutely the bottleneck. You cannot have a cloud that scales in seconds if you're waiting for Dave to finish his coffee. So SDN separates the brain of the network, the control layer, from the muscle, the actual physical switches.
So the brain becomes software.
Exactly. The software tells the switches what to do instantly. It's all programmable. When you click Create Server on AWS, SDN is what automatically creates the virtual network, assigns the IP address, and sets the firewall rules. It turns networking into code.
Wow. So we virtualized the computer with VMs, we virtualized the apps with containers, and now we virtualize the actual cables with SDN. It really is Inception all the way down.
It is. We have abstracted away the physical hardware almost entirely.
But, and here comes the dark cloud on the horizon.
Yeah.
We talked about how secure Type 1 hypervisors are and how sandboxes are safe places to detonate viruses. But are they perfect?
Nothing in security is ever perfect. And there's a concept that keeps security researchers up at night. It's called VM escape.
That sounds like a Prison Break movie.
It essentially is. Remember, a VM is just software running on a host. If there's a bug in the hypervisor itself, a flaw in the code that creates the whole matrix, a really sophisticated attacker could write a virus that breaks out of the virtual machine.
Wait, so I detonate a virus in my sandbox, thinking I'm safe. But the virus realizes it's in a simulation, finds a crack in the wall, and jumps out onto my real computer.
Yes, and not just your computer. If this happens in a public cloud where you're sharing a server with lots of other companies, an attacker could theoretically jump from their VM down to the hypervisor and then pop up inside your VM.
That is terrifying. That's like hearing the guy in the hotel room next to you just walk through the wall.
It's extremely rare, and companies like Microsoft and Amazon pay millions of dollars in bounties to hackers to find these bugs before the bad guys do. But it just challenges that assumption that the cloud is magical. It's not magic, it's code. And all code can have bugs.
The sandbox has a leak.
Well, on that slightly ominous note, I want you to look at your setup today. Are you running a Type 2 hypervisor? Do you have enough RAM, or are you starving your host?
And pay attention to the cloud services you use every day. Are you building the kitchen with IS, or are you just eating the pizza with sauce? Thanks for diving deep with us. Go check your BIOS for that VTX switch, and we'll see you next time.
Stay secure.